I'm A.T. Biju, an associate professor at the Department of Organic Chemistry, Indian Institute of Science, Bangalore. So we basically work in two areas. One is organocatalysis using N-Heterocyclic carbenes. We use this area of catalysis for forging carbon-carbon and carbon heteroatom bonds for the construction of various carbocycles and heterocycles. Specifically, we use this transition metal free catalyst for the enantioselective construction of carbocycles and heterocycles. On the other phase of our work, we are also interested in the chemistry of arynes, where one can synthesize a variety of benzo-fused carbocycles and heterocycles under transition metal free conditions using benzynes as the highly electrophilic intermediates in organic chemistry. We know that fluorine containing organic compounds are very important building blocks in biologically active molecules and pharmaceuticals. This is because almost 20% of the pharmaceuticals as well as 40% of the agrochemicals contain fluorine as a constituent atom in the molecule. The important aspect of fluorine in an organic compound is the remarkable ability of this fluorine containing molecule to improve the lipophilicity and the metabolic stability of a drug. So in short, fluorine containing organic molecules are very important. On the other hand, catalysis is one of the sustainable method for forging carbon-carbon and carbon heteroatom bonds, thereby leading to the construction of a wide variety of carbocycles and heterocycles. So with the support from Professor Tatiana BESSET and Professor Thomas Poisson and the continued support from CEFIPRA, we thought of combining or merging the two areas, the organofluorine chemistry and the N-heterocyclic carbene-based organocatalysis, for the selective incorporation of fluorine in organic molecules. I should mention that this is only possible the complementary expertise between the French team and the Indian team came together with the support from CEFIPRA, otherwise this would not have been possible. So the French team actively working in the area of fluorine chemistry, the selective incorporation of fluorine, and with our experience in the area of N-heterocyclic carbene organocatalysis, we proposed or we envisioned the merger of organofluorine chemistry with N-heterocyclic carbene for the incorporation of fluorine in organic molecules. This was the objective of our CEFIPRA project. As I indicated, almost 20% of the pharmaceuticals and 40% of the agrochemical compounds contain fluorine, the smallest element in the periodic table. Although the organofluorine chemistry for incorporating fluorine in organic compounds and carbene-based strategies for constructing compounds are well known, there are no strategies to incorporate or to merge these two concepts to realize the selective incorporation of fluorine in organic compounds. This technique is very important because the introduction of fluorine selectively at the alpha, beta or gamma position of a carbonyl compound will be very interesting, and use of chiral N-heterocyclic carbene can do this process in an enantioselective fashion. That means we can introduce fluorine in an organic molecule in a chiral or enantioselective fashion to construct molecule with high enantio purity. These molecules are probably very interesting because analogous molecules or the similar molecules of what we synthesize are non-pharmaceuticals. So we believe that the compounds we synthesized as a part of this CEFIPRA project by combining fluorine chemistry with N-heterocyclic carbene organocatalysis could find some application as pharmaceuticals in the near future. So the CEFIPRA project on merging fluorine chemistry with NSC catalysis helped both of us, not only me but also Tatiana and Thomas a lot. This helped us to know more about fluorine chemistry for me, because I know I have some experience in N-Heterocyclic carbene organocatalysis, and Tatiana and Thomas, they had the expertise in fluorine chemistry. So the project supported by CEFIPRA helped us because this is completely complementary to each other. So this helped me to get some information about fluorine chemistry, and I'm sure this helped Tatiana and Thomas to get more information about N-Heterocyclic carbene organocatalysis. In addition to this, the project we started when I was in NCL Pune Organic Chemistry Division, and then I moved in 2017 to my present position at the Department of Organic Chemistry, IISc Bangalore. And I'm sure that both these institutes and also the University of Rouen benefited a lot from this project, which is funded by CEFIPRA. We all, three of us, Tatiana, Thomas, and I, really acknowledge the support from CEFIPRA in running this project very successfully with the synthesis of a variety of fluorinated organic compounds in enantiomolecule. So as I indicated, our project funded by CEFIPRA is on merging organofluorine chemistry with N-Heterocyclic carbene organocatalysis. So what we did was, we took an aldehyde, treated with a carbene in solution, and an electrophilic source of trifluoromethylating reagent, so specifically the Togni reagent, and we developed a strategy for introducing the CF3 group selectively at the alpha position of a carbonyl compound. This was very impacting because there are not many strategies for selective introduction of trifluoromethyl group at the alpha position of an aldehyde. And we also demonstrated a strategy for the enantioselective alpha trifluoromethylation of aldehyde using N-heterocyclic carbene catalysis and Togni reagent as the CF3 source. And these results were published in Organic Letters, a publisher from the American Chemical Society journal. In addition to this, we also demonstrated the enantioselective construction of trifluoromethylated heterocycles such as indoles, oxazole derivatives using the combination of N-heterocyclic carbene catalysis and fluorine chemistry. These works were published in Organic Letters, Chemistry, European Journal, etc. So these are all possible with the continued support and funding from CEFIPRA.
Long live India and France friendship.